going to see how the Chirp Anywhere IoT platform operates. The screen that you see here is our domain modeling screen. The one on your left gives us all the components that are a part of this particular domain. Right now we are, this domain that you see here is for a ship. So what you see here are components of a ship's engine. Now, say if you want to model an engine room, you drag and drop components, and the components can be interconnected like this. For example, as you see here, I've attached a lube oil pump to a main air compressor, and say for example the lube oil pump is connected to a turning gear. There it goes. And say we attach a vibration sensor to it. So there we go, and these components can be named to whatever we want. Say I call it main air 1, and I call this lube oil pump 1. Say I call this TG for turning gear, and let's call this V1. All right, now this thing is going to get saved. Now what you see here is our main UI. As you see here, there is an emergency air compressor and main air. Emergency air compressor was something that I've modeled already, so this is what shows there, and the one that we modeled just now shows right below it. Now if you go to any one of the systems, you'll see all the subsystems listed there. As we connected a lube oil pump, these are the machine subsystems, and the sensors, the only sensor in the entire system is the vibration sensor, which we named V1, which is attached to the turning gear, and we have few operation modes. Now the next step would actually be collecting data from the vibration sensor, but because we don't have actual vibration sensors to feed data into the system, we have created simulators. Now the simulator data are actually Excel files once they come up. So we have these two Excel files in the systems, M1 and M2. And the system has two modes, training mode and execution mode. So these are the two modes. Let's put it back on training mode and start streaming data. Now the system is actually learning the behavior of the machine that we modeled just now. So it can be trained for a day, a week, an entire cruise or whatever, an entire trip in the sea. It depends on system to system. Certain systems get trained pretty quickly, and certain systems like the ship's engine needs a lot of time to get trained, probably an entire voyage. So that's what this is for. And once we are sure that it saw everything that is there to see, we put it back into training mode. Once we put it back into training mode and go back to the screen, what we will see in a minute, or it's probably loaded here, are the clusters that it created. So these are the different modes that it saw during training. Now whenever any new data comes and it falls outside of these recognized clusters, the system detects it to be an anomaly and learns from the user that what that anomaly means. For example, that anomaly can be, say, rough seas, which is not really a fault. So they can be marked as non-anomalous data, and it would be fed back to the existing model. But if the anomaly is in fact a problem with the machine, then that data is tagged. So next time the machine sees that, or it sees circumstances that problem is about to happen, the machine predicts, and it lets the user know that a certain problem is about to happen or a certain mission is about to be failed. Thank you.